Here's an example of how to use Hess's law, or the steps for Hess's law. Uh, we've got some rules that we need to follow. Whatever we multiply our chemical equation by, we have to do the same to our delta H. If we reverse our chemical equation, we're going to reverse the sign on delta H. And then finally, the delta H for the overall reaction that we're trying to find is the sum of the individual delta H's for those steps after they've been manipulated. So here's what we've got. We've got an equation up here, and we're trying to find the delta H for this reaction. And I likened this to, or analogized it, or, well, made an analogy, that this is kind of like the picture on the box for a puzzle. And these are my pieces. What I want to do is I want to take the pieces and make the picture on the box. And again, we get to do some things to this like multiply or reverse, and then we add them up at the end. So let's go ahead and get started on this. First thing I'm going to do is I'm going to try to look at my picture on the box and try to match something up with some of my puzzle pieces. The first thing that jumps out at me is I've got this on the left side, this on the right side. They match, except for this 2 out in front and the fact that this is on the left and this is on the right. So what I'm going to have to do to this equation is I'm going to reverse it and multiply by 2. So that's what I'm going to do with this first equation. I'm going to reverse it and multiply by 2. So when I reverse it, I'm going to get, and multiply it by 2, I'm going to get 4 HNO3 is going to give me, so this now gets put on the left instead of the right, and then all this stuff goes over to the right. So, and I'm multiplying, so it's going to give me 2 N2O5 plus 2 waters, 2 moles of water. Again, I can only use my puzzle pieces once. I should probably write that down. So can only use each step puzzle piece. We'll refer to it as a puzzle piece once. Alright, so let's go back to our problem here. The next thing that jumps out at me is I've got, what have I got? Oh, nitrogen. I've got nitrogen here, and I've got nitrogen here. The only difference is that this is a half and this is 2, so I need to multiply this by something to get to 2, and that's going to be 4. So times 4. So let me go ahead and do that then. I can leave, I don't have to reverse this because this is on the left side and this is also on the left side. So let me go ahead and multiply by 4. So 4 times a half is going to give me 2N2 plus 4 times 3 halves is going to wind up being, let's see here, that cancels. 4 times 3 halves, let's go over here really quick. 4 times 3 over 2, that becomes 2. 2 times 3 is 6, okay? So that's going to be 6 moles of oxygen. Let's get rid of this in case I need it later. Need the space later. Plus 1/2 times 4 is 2 again, 2 moles of hydrogen. I usually like getting these arrows lined up so that I can makes it easier when I go and cancel, but I'll just be careful. And then on the other side is going to be 4 nitric acids, 4 times HNO3. Right, actually, you know what I can do? I can move that over, I'll bet. Let's see if I can do this. Nope. Let's move it over further. Let's move it over further. Oh, I want to move that up a little bit. Hey, there we go. Fancy. All right. All right. Last but not least, I've got one piece of the puzzle left to use, and let's take a look here and see what I've got. Um, I've got hydrogen on this side. There's nothing, well, other than the oxygen, there's nothing in this puzzle that I need. What this becomes more of is what I need to get rid of. Okay, right now, what I've got is I've got 6 oxygens on this side, and I only need 5. And I've got water over here, and I need to get rid of it. So really, here's what I'm looking at. I've got water here, and I need to get rid of it. I'm looking at this. This puzzle piece is more of a subtraction piece than an addition piece. It's kind of a little different way to look at it. Let's do this in a different color. Let's take this in pink. I've got this, and I've got this, and I need to get rid of it. So what I'm going to do is I'm going to reverse this, and I'm going to multiply by 2 because I've got 2 waters over here, and I really need 2 waters over here to offset that. So I'm going to reverse it and multiply by 2. This is kind of tough, but you see how it works. There's nothing in here that I need. In fact, there's stuff I need to get rid of, and I need to use this puzzle piece to do that. I'm up to 6 waters, or excuse me, 6 oxygens here. When I reverse this and double it, I'm going to wind up with an oxygen on this side, and it'll help me get down to 5. Let me go ahead and do it, and you'll see what I mean. So I'm going to reverse this and multiply it by 2. So I wind up with 2 H2O on this side, and I wind up with 2 H2 on this side, and 2 times a half is 1. I wind up with an oxygen on this side. All right, so at this point, we're ready to go ahead and do our cancellations of things. So here's what I've got. I've got 4 nitric acids on one side, 4 on the other. That goes away. I've got 2 hydrogens here, 2 hydrogens there. That goes away. Here's the water that I was talking about. I needed to get rid of this water. There it is. It's gone. And I've got 1 oxygen over here, and that takes this down to 5. So what I'm left with is this, and this, and 5 of these. So let's go ahead and write this down. I've got 2 nitrogens plus 5 oxygens produces 2 dinitrogen pentoxides. 2O5. Does that match the box? It does. Look at that. 2, 5, 2. It matches the box. So I'm there. It's a match. So at this point, I can do the same thing with my delta H's and calculate that delta H for the overall reaction. So let's go ahead and do that. With this first one, I'm going to reverse it and multiply by 2. So it's going to be 2 times a positive 285, because it's a negative now. I'm going to reverse the sign. 285.8. That's equal to, again, I should probably move that over so I have some room. Let's do that. 2 times 285.5 is equal to, and I'm going to do that. I'm going to reverse and double this. So again, this becomes a positive. It's a negative here. I'm going to double it and make it and reverse the sign. So it's going to be 2 times a positive 76.6 is going to be equal to, and then this last one I'm just going to quadruple that, so it's going to wind up being 4 times, I'm not reversing it, so it stays negative 174.1 equals. All right, let's go ahead and grab my calculator, and let's do some of this. 2 times 285.5 is going to be equal to 571. 571 kilojoules, and then 2 times 76.6, 2 times 76.6, 153.2 kilojoules, and then 4 times 174, 4 times a negative 174, sorry, negative 174.1 is going to be equal to negative, what was it, negative 696.4 kilojoules. Let me double check that. Yeah, 696.4 negative. All right, so now I'm ready to total these up. So it's going to be the answer plus 153.2 plus 571. Hit enter, and we get 27.8 kilojoules. So if I total these up, I get 27.8 kilojoules. All right, double that. Yeah, double that. Yeah, that looks about right. And quadruple that. Add those guys up. This is about 600 and something. Yeah, it looks pretty right. Let me double check that math here. So 571 plus 153.2, no, minus 696.4. Yeah, 27.8. Okay. And again, that is the delta H for the overall reaction, which is this reaction right here.